Before starting the next lesson, try this warm-up. Solve the equation by graphing. X to the exponent 5 plus 2x to the exponent 4 minus 9x to the exponent 3 minus 18x squared plus 14x plus 28 equals 0. So pause the video, use desmos.com/calculator in order to solve this equation by graphing, and then come back and see how you did. So when you typed in y equals this is what your graph would have looked like, and all the x-intercepts are highlighted here. So you should have got all these different answers for x. So x equals negative 2.646, negative 2, negative 1.414, 1.414, and 2.646. Those are all the possible values of x to solve this equation. So this whole unit so far has been about algebra and solving equations, and now we're actually going to solve some problems using all these skills. So we're going to solve real-world applications that involve a polynomial equation. Here's the first example. A box must be constructed from a piece of cardboard measuring 30 centimeters by 24 centimeters. It must be folded on the dotted lines, and the capacity, or volume, must be 648 centimeters cubed. Determine the dimensions of the box. So here I have the diagram started for me. There's no numbers on it though, but I can see the solid outline is the piece of cardboard, and the dotted lines are where the box is going to get folded. Okay, so this line indicates that this flap is going to get folded up, this flap is going to get folded up, and this part is going to get folded over to be the top of the box. It's kind of like a pizza box. All right, so we can start putting some measurements on here. It says it's 30 centimeters by 24 centimeters. Okay, so I've got the length is 30 centimeters, the width is 24 centimeters of this piece of cardboard. Now it's going to be folded on the dotted lines. Now I don't have a width of the spaces here, but we're going to assume that this is all going to be folded the same distance, because if this flap goes up, it's going to have to be the same as this middle flap, because that's going to be the height of the box. Picture a pizza box. Okay, so this part right here is going to be the height of the box when it's all folded. But we don't know what it is, so I'm just going to call it x. So this width is going to be the same as this, and the same as this, and this. So if I want to find the dimensions of the box, I need to find the dimensions, length, width, and height when it's all folded up. All right, so this length from here to here is going to be the total 24 centimeters minus an x here minus an x here. So this length from here to here is going to be 24 minus 2x. Now to find the distance from here to here, it's a little trickier. I know the total distance, the whole length is 30 centimeters. But I need to subtract these x's. There's two of them. So this is going to be 30 minus 2x, and then cut that in half because there's two equal pieces here that fold on top of each other. So 30 minus 2x divided by 2. So now I have my dimensions, kind of. I have height of x, length of 30 minus 2x over 2, and a width of 24 minus 2x. So now I need to make an equation. Well, I know the capacity is volume, so volume is length times width times height. So volume is equal to, well, x times 24 minus 2x times 30 minus 2x over 2. Now I know the volume is 648 centimeters cubed, so I'll plug that into my equation. And anytime in this unit where I've been solving an equation, I've had to set it equal to 0 first, so I'll manipulate my equation. I'll move that 648 to the other side. So now I have 0 equals x times 24 minus 2x times 30 minus 2x over 2 minus 648. Okay, so I have an equation, I can solve for x. Now, I wouldn't go ahead and try to expand and simplify and factor and solve by factoring. That's going to get way too messy. We know another way. In the last lesson, we looked at solving these equations using technology. We used the graphing calculator. So that's what I'm going to do. So I just go to Desmos, I type in my equation, and to find when it equals 0, I'm looking for my x-intercept. So there's 3 of them in this case. So there's 3 possible values for x, and we're going to have to figure out what the dimensions are in each case. Okay, so if x equals 3, the length, okay, now length, width, and height, it doesn't matter which is which, but one of the dimensions is x, which is 3 centimeters. The other one was 24 minus 2x, which means 18 centimeters. The other dimension was 30 minus 2x over 2. Well, that is 12 centimeters. So, in this possibility, the dimensions of the box could be 3 centimeters by 18 centimeters by 12 centimeters. Now let's look at the second possibility, when x equals 6. So if x equals 6, then length is 6 centimeters, width is 12 centimeters, height is 9 centimeters. There's one last possibility if x equals 18. If x is 18, then the length is 18, but whoa, what's this? The width is negative 12 centimeters, the height is negative 3 centimeters? Obviously, these dimensions don't actually make any sense. You can't have a negative dimension on a box. Maybe if there was a black hole mentioned, but there was no mention of a black hole. So really, the only dimensions that make sense are the 2 possible outcomes up here. So I can say the dimensions of the box are either 3 centimeters by 18 centimeters by 12 centimeters or 6 centimeters by 12 centimeters by 9 centimeters. Both of those cases give me a box with that same volume. But these dimensions are inadmissible. And here's my second and final example for this lesson. The height, length, and width of a box are consecutive integers, with height being the smallest. If the length and width are increased by 1 and the height is doubled, the volume will increase by 120 centimeters cubed. Determine the original dimensions of the box. Okay, so it's a box. We have height, length, and width, the 3 dimensions of the box, and those values are consecutive integers. So what I mean by consecutive integers are integers that occur one right after the other. For example, 1, 2, and 3, or 4, 5, and 6, or 7, 8, 9, okay? 20, 21, 22, those are all consecutive integers. It says height is the smallest integer. So I'm going to just use x to represent height, the smallest integer. So if volume is length times width times height, well, my 3 dimensions are going to be, start with the smallest one, x times x plus 1 times x plus 2, because they're consecutive integers. This one's going to be 1 more than this one. This one's going to be 1 more than this one. Okay, so I have the beginnings of an equation. And don't forget to define your variables whenever possible. So I'm letting v represent the original volume of this box, and x represents the height in centimeters. Now it says if the length and width are increased by 1, stop right there for a second. Length and width I'm calling these, so x plus 1 and x plus 2. Well, if they're each increased by 1, this is going to become x plus 2, and this is going to become x plus 3. Back to here. And the height is doubled, so instead of x, it's going to be 2x. The volume will increase by 120 centimeters cubed. So instead of v, it's going to be v plus 120. So if I put all that together, I end up with this equation. Length and width have each been increased by 1. Height has been doubled. Volume has increased by 120 centimeters cubed. Okay, so I have 2 equations and 2 unknowns. So I can take this equation and actually substitute it in right here. Because if this is what v is equal to, then I can replace b with that. So now I have an equation with just one unknown value in it, x. It's a little bit complex, but I can still work with it. So just to recap, the original volume is height times length times width. When the volume increases by 120, the height doubles, the length and the width each increase by 1. Now, if v is the original volume, then I can just replace the original volume with this equation that I set up originally. So then I get this full equation. Now remember, if I want to solve an equation, I have to make it equal to 0. So I'm going to take all of this and move it to the other side. And now I have an equation equal to 0. Don't try to factor it or anything like that. It's too complicated, so we're just going to use Desmos again. So I'm going to type y equals this into Desmos, and we'll see how it looks. So when I type it into Desmos, I get this graph. In this case, there's only one x-intercept, so there's only one value of x that satisfies this equation. So the equation equals 0 when x equals 3. Now the question asked me to determine the original dimensions of the box. And if you'll recall, the dimensions were x, x plus 1, and x plus 2. So that means my dimensions are 3, 4, and 5 centimeters. So the original dimensions of the box were 3 centimeters by 4 centimeters by 5 centimeters. Okay, so hopefully you got a little bit of a taste on how we can actually solve some applications using polynomial functions. And anytime you have a word problem, chances are it's easiest to solve the equation by graphing. Try some practice questions and let me know if you need some help.